dear students, good morning. Hope you all fine, and please take care about your health as well as, and most importantly, okay, this is a tough time, I agree, but we have to prepare properly. Okay, so cooperate with us. And yesterday we discussed atomic structure by means through YouTube live, but unfortunately we failed, frankly speaking. So many people was not happy. I'm very sorry for that. But now I won't repeat that. First periodic classification I'll do like this, probably chemical bonding also. But afterwards definitely we will give you best. Okay. So as I mentioned in previous, definitely the best way we will give you, we will support you, and we will respond. I mean, if you ask any question, we will definitely respond fast. Pakka, sure. Okay. If I was not responded, suppose, then you called me, no problem. Okay, so this is a very important time for us, and you have to score very good marks in our NEET exam or whatever, CET or whatever. Okay, but you should be very good in your life. All the best. Okay, now we will enter into periodic classification. So quick revision we will have, because in one day we have to finish. So directly I will enter into modern periodic table. Just go through that Mendeleev, because mostly through Mendeleev, from Mendeleev nobody will ask you questions. So in modern periodic table, to understand, we must know that Moiler diagram. So what is the Moiler diagram? 1s. So everybody knows that. Moiler diagram in atomic structure, 1s, and here you have 2s and 2p here. So next is 3s, 3p and 3d you are having. Next is 4s, okay, 4p and 4d you are having here, and 4f. So as it's a shell number 1, 2, 3, 4, you know this already. And next is 5s and 5p and 5d and 5f, and one more will come, that is 5z. Please try to adjust. And here you are having 6s, 6p and so on like this. And here you are having 7s like this you have. So first, what subshell will fill according to above? Less energetic subshell will fill first. So the energy of subshell depends on n plus L value. So n plus L value is less here, so 1s first. N plus L value means, you know, na? N is principal quantum number, that L is azimuthal quantum number. So first 1s will fill, afterwards 2s, afterwards 2p 3s, afterwards 3p 4s, next 3d 4p 5s, next 4d 5p 6s, next like this you will have. Correct, sir? So first, what subshell is going to fill? S. So one more important thing, S can have maximum how many electrons? Just yesterday we discussed 2, and P can have 6, D can have 10, F can have 14 electrons, like that. Okay, so like this. So one more important thing you have to remember, first 1s, after 2s, 2s after 2p will fill. After complete filling only, next subshell will go to fill. So 2p will fill means, in 2p how many electrons you have to fill? 6. Okay, next, yes, 2, p 6, yes, 2, d 10 electrons you can fill. Why I am telling all these things, understanding? 3d after 4p, 4p after 5s, 5s after 4d, 4d after 5p, 5p after 6s, 6s after 4f will fill. In f how many electrons you can fill? 14 electrons you can fill. So in modern periodic table, which was given by Niels Bohr, what he said, there are 7 periods and 18 groups. I repeat, in modern periodic table, elements were filled in 7 periods and 18 groups. Everybody knows. Starts with S. Every period starts with S. Every period ends with P. Period means horizontal row. Group means vertical column. So 1s. So here 1s actually. Except this first period. First period is exceptional. In first period, S subshell only will fill. remaining every period, if you see second period, every period means this, starts with S, ends with P. So horizontal rows are called periods. Vertically what we are writing? Groups. So in second period you are having 2S and ends with 2P. You can check this. 2S after what you are filling? 2P. So 2P filled. So don't write 3S here because the 3S means that should be n value. N value 3 means the third principal quantum number should be equal to this third period. So according to that property is also present. That's why they was arranged like this. Third period. Third period starts with 3S and ends 3S after what subshell will fill? 3P. After 3P sir, in this one more subshell is there, no sir, I will fill 3D here. No. We have to follow energy order. 3S after 3P is less energetic. 3P after 4S is less energetic. So third period will finish with 3S and 3P subshells only. And come to this fourth period, you have to start with 4S. But 4S after what subshell is going to fill? 3D. 3D after 4P. 4P you have to stop here because every period ends with P only. So 4S and then 3D and then here 4P here like this. And if you see fifth period after 4P, what you have to fill? 5S. 5S means you have to go for new period or not, because 5 means fifth period. So here you will have 5S and 5S after what subshell is going to fill? 5S after 4D. 5S after 4D. 4D after 5P actually. Next, come to next period, sixth. Sixth period I have to keep one star there because 6S after 4F is coming. So there is a new subshell is coming. Here S only, S and P. Here in fourth D came, okay, and fourth and fifth periods are identical because 4S, 3D, 4P, 5S, 4D, 5P, SDP. But in sixth period you have to start with 6S, but here there will be a 4F. You see 6S after 4F, 4F after 5D, 5D na, 4F after 5D, 5D after 6P. So this here you have to keep one star as a 4F. Next, come to seventh. Okay, seventh period is identical to 6. You can check 6S, 4F, 5D, 6P over. Next 7S na. So 7S will come here. Understanding? So 7S and 7S after 5F will come. 5F and 6D and 7P like this. So here also you are having like this. Okay, so in first period, what subshells are going to fill? S and S. So what I have to say now? In first period, elements you have to classify in which differentiating electron enters into 1s orbital. This is important. I repeat. You have to place elements. Okay, in first period you have to place elements in which last electron enters into 1s. Suppose hydrogen 1s1. Electron enters into 1s subshell or not. So hydrogen belongs to first period. Here helium. Helium means 1s2. So in helium that second electron enters into 1s or not. So helium and hydrogen belongs to first period like that. So here lithium, if you see lithium 1s2, 2s1. So the last electron is this, not this one. Last means in 2s is the outer subshell. That we call as differentiating electron. Differentiating subshell also. This electron is called differentiating electron. So in lithium, the last electron enters into 2s. So lithium belongs to second period. Last electron we have to see. Like that, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and till neon. Okay, because P can have 6 electrons. Means 6 elements you can place in P. because starts with 1, ends with 6. So here, suppose last if you see neon, see 1s2, 2s2, 2p6. So last electron means 6th electron. Present in what? 2p. That means that neon is belongs to second period like that. So now you can say one more thing. In first period, how many elements there will be? 2 elements here. Number of elements. Number of elements in first period 2. Because S can have maximum how many electrons? 2. Now in second period there will be 8 elements. Why? Here S1 to 2 can be present. P1 to 6 is possible. So total 8 elements are possible. Here also 8 elements are possible. Here S2, D, 10, P, 6. So there are 2 plus S means 2, D means 10, P means 6. So 2 plus 10 plus 6. So 18 elements you can place. Like the same 5s 4d 5p similar. So here also 18 elements can be placed. Because S1 to 2, D1 to 10, P1 to 6. So like that 18 elements will have last electron in S and D and P. I repeat, here in 5s there are 2 elements, they have last electron in 5s1 and 5s2 here. Here 10 electrons from 4d1 to 4d10 here we have. 10 elements you will have last electron from 4d1 to 4d10. Here 6 elements are there from 5p1 to 5p6. That's why there can be 18 elements in 4th and 5th period. 6th period you can as usual this 4f and 5f we will write at bottom actually. 4f series and 5f series. As 4f, f can have how many elements? 14. This 5f 14. 14 elements as 4f series. 14 elements as 5f series we will write, but those 4f comes under 6th period, those 5f elements will comes under 7th period. So in 6th period there can be a 32 elements. How many elements? 32 elements you will have. Here also there can be a 32 elements by S2, F14, 10 and 6. 6 plus 10 plus 14 plus 2 like that. So longest period means 6th. 7th you will have incomplete. 7th period we call as incomplete period. 7th. 6th also 32. 7th also 32. Okay. 4 and 5 periods are long periods. These are what periods? Long period. This 6th period is a longest period. 7th you can place 32, but some are not at conformed. So this is an incomplete period. Incomplete period. Who is incomplete period? 7th one. Very, very important. Please have a look and write down all these things. And based on this, periodic table can be classified as S block, P block, T block and F block. This 4F and 5F you will have at bottom like 2 series as 4F series and 5F series. Okay. So S block will have how many groups? 2 groups, because S can have how many elements? 2. Because S can have 2 electrons, no? So S can have 2 elements. P can have 6. D can have 10. Like that, you have 18 groups. 2, 10, 2, here, 2, 10, 6. Because this 4F and 5F, I told you, that's why before only, written at bottom. So 2, 10, 6. So there can be 18 groups. How many? 18 groups. 1 to 2, 1, 2. Here 10, 1 to 10. 10 plus 2, 12. Here 6 groups are possible. P1, P2, P3, P4, P5, P6. Like that. So 18 groups are present. 7 periods are present. In every period, how many elements are present? I written there. So please note it down all these things. Okay. So if not written, just go back. Okay. Next, we have to discuss about some properties like that. Okay. About the periodic table only. So what is the D? What is S block element? What are the P block elements? What are the D block elements? What are the F block elements like that? Okay, if you see like first period, so first period if you see, you are having hydrogen as a 1s1 and their helium is a 1s2 you are having. And if you see that second period, what is that? Second period starts with lithium. Lithium you are having 1s1, and next beryllium you are having 1s2. Next starts with here boron and carbon, nitrogen, oxygen, 1 2 3 4, and fluorine and neon. So I'll write oxygen and fluorine and neon like this. So 1s1 here P1, so 2P1, 2P2, 2P3, 2P4, 2P5 and 2P6 like that. So you are having from P1 to P6 like that. Okay. So in second period these are the elements. Like the third period, fourth period same. Okay. Second and third same, and 4 and 5 different. Okay. Fourth period like that. If you see third period, if you see sodium and potassium and rubidium and cesium like this, and francium you have like this. So here starts with here again 2s1, and here magnesium, here 3s1 and here 3s2. 1s2 this one, sorry 2s2 this one, 2s1 and 2s2 because it is second period, no, I written wrong. So this is 3s1 and 3s2, that is 1s1, no, sorry, and here 3s1 3s2 and here 3p1 to 3p6 like that. So like that how many groups you have? 1 2 3 4 5 6 7 8 groups you have? No, because here from fourth period, what is this? Fourth period after potassium and here calcium, there will be elements from scandium to zinc, 10 elements. Starts from, this is actually 4s1, calcium is a 4s2, scandium is 4s2 3d1, and zinc is from 4s2 3d10 like this. So here 2, here 10, 2 plus 10, 12, and here after this scandium, here boron, okay, and here boron, aluminium, gallium like that, indium you are having, here germanium you are having, nitrogen, phosphorus, arsenic you are having like that. Here again 3D, again from 4p1 to 4p6 and so on. Here neon, here argon and krypton, so here you are having 4p6. So why you are writing all these things? To know the electronic configurations. So now you can write what is S block configuration. Simply NS122. You can write. What is the D block configuration? NS122 you can write, and N minus 1 D1 to 10. Why 1 to 2 I written? Because for chromium and copper we use 4s1 3d5 chromium. Copper 4s1 3d10 we will write. That's why I written like this. Hope you understood. Okay, so for P block how to write? Means for P block these are coming after yes, no. So simply NS2 NP1 to 6. So this is S block configuration. What is this? S block configuration. This is D block configuration, and this one is P block configuration. Like that you will have F block also. F block coming from what? Actually 4F. 6s after 4F coming. 4F, F can have how many elements? 14. 1 to 14 like this. So what you can write after actually 6s and one element will come in middle 6s. So actually here you have 1, 2, 3, 4, 5, 6. It's the sixth period actually. Okay, here beryllium, magnesium, calcium, strontium, barium you are having, and afterwards radium you are having here. Understanding everyone? This is S block actually. Here after this lanthanum you are having. Lanthanum actually it is actually 6s1 and this is 6s2, but this is 5d. But lanthanum after from lanthanum after you are having lanthanides 4F series. Okay. So what are lanthanides? After lanthanum you are having lanthanides. After actinium you are having actinides. So 4F 1 to 14 you are having lanthanides. Okay. Lanthanum don't consider. Okay. So Ce to Lw Lawrencium, thorium to Lu, sorry, lutetium. Here you are having 4F1 to 4F14 actually like this. Okay. So you are having like this 6S you are having, 5D you are having for F block, 4F1 to 14 you are having. It is from 58 to 71, total 14 elements. This lanthanum is 57 is the atomic number. How to have atomic numbers also let's see. So 6s 5d 4f. So what is the configuration you can write? This is ns, 5 means n minus 1 and 4 means n minus 2 f. Here also n minus 1 by written understood. 4 n value. 4 minus 1 3. 4 minus 1 3. So that's why we written d block. So now you can write ns 1 to 2 or simply ns2 you can write. N minus 1 d 0 to 1, n minus 2 f 1 to 14. 0 to 1 why I am writing? Sometimes to get half filled you will write 1 electron here, otherwise d0, d1 actually. Sometimes d0 also we write to get half filled here or full filled here. Actually d1 normally. Understanding everyone? So these are about configurations of S block configuration, P block configuration, D block configuration, F block configuration. NS2, N minus 1 D0 to 1, N minus 2 F 1 to 14. So these are about configurations. And one more important thing, both S and P block elements, total 4 blocks I said no, both S and P block elements except noble gases are called representative elements. What they are called? Representative elements. Why noble gases are not representative elements? They are chemically inert. They have octet configuration. They have what configuration? Octet configuration there. Who are having octet configuration? Noble gases. That's why they are not representative. So they don't have any particular comparable properties. They are completely different noble gases. That's why noble gases we use as inert gases. They have octet configuration. Helium has a duplet configuration. Okay, so many times I told you how to have atomic numbers. Okay, without by-hatting. So left side, as I said, the left side what you have hydrogen, lithium, sodium, potassium, rubidium, and cesium and francium you have. So actually first period consists of 2 elements and 8 elements, 18, 32 elements and 32 elements you have. So this actually fourth period I am writing. Okay, and here you have sixth period. So 2 are important. So left side when you want atomic numbers as going down like this, simple, you have to write its atomic number is what? 1. Atomic number is 1. So if you want atomic number of this lithium, please add total number of elements in above period for the above atomic number. I repeat, you want lithium atomic number, right? So add number of elements in above period, means in first period how many elements are there, those many elements you have to add for the above element to lithium. Above element to lithium who is there? Hydrogen. So atomic number of lithium means 1 plus 2, 3. So this 3 plus 8, 11. 11 plus 8, 19. Here above only we have to add. Understanding? So here 19 plus 18. 19 plus 18, 37. 37 plus 18. I think so 55 plus 55. 55 plus 32, 87 atomic numbers. And if you want from this actually potassium, same calcium like this also. So calcium and afterwards here strontium, and here barium and radium. These atomic numbers you can write, not a problem. But after this S block, this is S block, right? Here what you have in S block? Here magnesium you have, and here beryllium you have, like this. So here if you know, this is 4 and this is 12 and this is 20 and this is 38, and so this is 38 and this is 20 and this is 12 atomic number, like that. Okay, so it's 56, like this we can write. But here after calcium you have scandium. This is actually belongs to what? D block. Scandium, and here last element is zinc. Okay, so scandium is how much? It's 21. So now also same story. For this 21, if you add the same period elements, above period elements, I want scandium after actually Y. Suppose for yttrium I want atomic number, means what I have to do? This above element to this yttrium is the scandium, its atomic number is 21. For yttrium, above period elements. For yttrium, what is above period? Fourth period. In fourth period, how many elements are there? 18. 18 plus 21, I will get 39 is the atomic number. Okay, so next is here, same yttrium, and here lanthanum you are having. Same, 39 plus 18, you are having 57. Here. Of course, here also you have. Okay, but I written 57. But if you, even without writing this, here only you can write atomic numbers. Even you don't know this. Okay, 39. In this period, how many elements are there? 18. 39 plus 18, like that. Even actinium is 89, you will have, like that. So here, but right side, suppose zinc 30. I want zinc, actually cadmium, and here cadmium here, and here you have a mercury, like this. Okay, suppose I want for cadmium, what to do? Suppose cadmium I want. What to do? Here 30. So here what I have to do? In previous, if I want for yttrium, for this atomic number, above period elements I was added. Now not like that. In that side, I want cadmium atomic number. So in this period, so cadmium is belongs to what? Fifth. So in fifth period, how many elements are there? Those we have to add to above atomic number. So cadmium above is what? 30. 30 plus this 18. Below 1 we have to add. Because cadmium is coming after all these elements. Yttrium, zirconium, niobium, molybdenum, technetium, like that. So here 30 plus 18, so it is 48. So here same, I want mercury, 48 plus 32 I have to. So 48 plus 32, 80. 80 you will have, like this. Understanding? If you do 48 plus 18 is atomic number of mercury. No, don't do that one, because these are coming after this. Understanding? Left side above atomic number, above period elements, but right side above atomic number but period number of elements below you have to consider. Below period elements you have to add. For 48, so for cadmium, mercury is belongs to this particular, so 32. These you have to add. Very important. Even if you want, suppose here 80 plus 32, 112 by m you will have, 112 you will have here. So these are about D block atomic numbers. Why you are giving these are pakka questions? They will give atomic number, they will ask group number and period number. They will ask. Suppose 47 comes under, okay, sir, 47 D block, sir. It comes under 1B, sir. Because actually I forgot to tell you, here we called as 1A group and this is 2A group, but here you have 3B actually. Here you have 3A, 3A to 8A you will have. These are called P block actually. P block atomic numbers also you can have the same manner. Above period element, above period atomic number, above period element atomic number and below one total number of elements you can have like that. But here 3B, 4B and so on, 8B you will have, sir. 8B consists of 3 groups, 1, 2, 3 like this, and 1B and 2B. This 2B, 1B means actually copper and silver, gold, AU. This comes under 1B. Suppose 47 its group number and period number means group number is 1b and the silver is belongs to 5th period. Like that you have to say. Its configuration also simple. Okay, 5th period. So it is 5s. 5s, okay. 5s2. Okay, and this one 4d because ns and n minus 1 no. So 4d 9. So exceptional configuration. So 5s1 and 4d 10 like this. Suppose cadmium, okay, it belongs to 5th period. So 5s1 and comes under 4d 10. 5s2 4d 10 because cadmium belongs to 5th period. So 5s. Outermost should be period number. So n and n minus 1. So 4d like that. You can write electronic configurations also. If you want any noble gases like helium, neon, argon, krypton, xenon and radon like that. So same story. So you will have 2, 10 like that you will add. Okay. So 2 and here 10 because above period no sorry same period elements. Above period means it will be different. So neon atomic number you want. So for 2 because above 2 neon is helium 2 and 8. So 10 like that. So argon same story. Above 2 argon is neon so 10 and in argon period means third period how many are there? 8. So 18 is the atomic number. So like this you have to consider group number and period number and atomic numbers. Hope you can understand all these things. Please have a screenshot useful how to write electronic configurations also. Suppose if you want krypton, same story. 18 and in krypton comes under 4th. 4th is 18. 18 plus 18, so it's 36. 36 is the atomic number. You can have like that. So xenon, in this xenon 5th, 18. So 18 plus 36, 54. Like that you can write their atomic numbers also. Okay, so these are very very important electronic configurations, everything. And next we have to discuss about some periodic properties. What we have discussed? Periodic properties like atomic radius, ionization potential, electronegativity, electronic affinity, what happens. So we have to discuss about periodic properties. So first if you see atomic radius, as going down atomic radius increases because as going down electron enters into new subshell. Correct? Lithium 2s, sodium 3s, next 4s, 5s. So as going down atomic radius increases. So atomic radius from left to right decreases. Left to right atomic radius what happened? Decreases. And what are the atomic radius in lanthanides? In lanthanides atomic radius almost same. Atomic radius in lanthanides is almost same because of what? Lanthanide contraction. What is that? Lanthanide contraction. That is due to shielding effect or screening effect. Shielding effect or screening effect. What is that screening effect? Screening is familiar to protection of outermost electron by innermost shell. So what is the order of shielding? S greater than, P greater than, D greater than, F. Correct or not? So like this, atomic radius actually depends on the screening also. Screening means outermost subshell electron is protected by innermost like this. If screening is more, atomic radius is inversely proportional to screening. Inversely proportional to screening effect. Screening effect is more, directly proportional. Screening is more. Screening effect is directly proportional to atomic radius. Sorry for that. As you are going away, means inner subshell is protecting properly, then outer electron will away from the nucleus. When away from the nucleus means distancing. This is inner subshell, this is outer. this is protecting properly, then outermost electron will be pushed. Certainly, this outermost electron away from the nucleus. Certainly, what happens? Distance increases. Okay, so screening effect is this. This is the order of shielding. But in lanthanides and actinides and atomic radius, not only there, lanthanides, actinides, 4F, 5F, and even 3D, 4D, 5D, there also there is almost similar atomic radius due to this pore shielding. D and F are pore shielding. Shielding or screening, both are same. Due to pore shielding effect, what happened? They are not protecting properly. That means inner subshells is not protecting outer subshells properly. Certainly all elements have some small radius because outer electrons are coming towards nucleus. Certainly what happened? All have similar radius. That contraction or that decrease in radius is called lanthanide contraction. What is that? Actually talked about, suppose here scandium you saw that okay, here yttrium, here lanthanum, like this. Actually size, what must happen? Size must increase, but here due to pore shielding, last subshell is coming closer this one. Actually here you have like this, you're somewhat more closer, you are having like this. So but almost coming same because that inner subshell is not protecting properly. So these are coming because here inner subshell is 4F. So this is not protecting properly. So this outer electron is coming. So atomic radius, what happened? Decreases. That decrease in radius is called pore shielding effect. Atomic radius depends on screening effect. Screening effect is more, then atomic radius is more. If screening is less, then radius will decrease. That decrease is called contraction. Okay, so radius also depends on nuclear charge. So as nuclear charge is increasing, then outer subshells will attract towards nucleus. So from left to right, that's why that radius is decreasing. So radius types, please go through that radius. Atomic radius, actually distance from nucleus to outermost shell. But radius depends on nature of bond, because atoms are not in free state except noble gases. Even noble gases, there is a van der Waals radius. There are types of radius. One is covalent radius, metallic radius, and van der Waals radius. Van der Waals radius. This is order of radius. Covalent radius means one into another. Metallic radius means one adjacent to another, like this. But van der Waals means one away from the other. No adjacent and no attachment here, just half of the internuclear distance we have to take. Van der Waals radius is big. This is covalent radius. This is small because one into another. Okay, one more is there. Ionic radius, cationic radius, anionic radius. Cation, positive ion. Positive ion is cation. Cation always have smaller radius than its atom. What atom? Corresponding atom. Suppose Na plus and Na. Who have more radius? Na. Corresponding atom, like this. And one more, as positive charge increases, cation size decreases, like this. Similarly, as the negative charge increases, then what happens? Anion size increases, like this. Both two things you have to write. Okay, in isoelectronic species we will say radius. Isoelectronic species means what? Having same number of electrons. Okay, isoelectronic species, like that. This is about atomic radius. Please write down. What is lanthanide contraction? I said lanthanide contraction means decrease in atomic radius due to pore shielding effect of inner D and F subshells. That is lanthanide contraction. Hope you understood what is lanthanide contraction and everything. Okay, so shielding effect order also I was given. So shielding effect depends on what? Inner subshells. S, P, D, F. If inner subshells are D and F, then shielding is less. Certainly radius will decrease. That's why In D block and F block, they have almost similar radius. That's why D and F block, we call them have similar properties. See, transition elements, D block elements are called transition elements. Okay, in second year also we have D and F discussed. Okay, so except zinc, cadmium, mercury, the remaining elements are called what they call transition elements. Why they have similar properties? Due to lanthanide contraction, that you know already. Next one is ionization potential. Same story, left to IP1 and IP2. What is ionization potential? Just yesterday also I said. The amount of energy required to remove electron from neutral isolated gaseous state atom. Suppose an X gaseous state atom, isolated means single state, no bonding. For that we will give some energy. Okay, then it converts to X plus gas. Okay, like this, plus 1 electron. Okay, otherwise this delta H IP, and from X plus is a gas, this is IP2, and one more electron you are removing. First we removed one electron and found X plus. From X plus, if you are removing that second electron, then you will get IP2, because you are removing second electron from X. First electron you remove, that is IP1. Second electron you remove, that is IP2. Don't think without IP1 IP2 exists. No, after IP1 IP2 exists. Then X plus 2 plus 1 electron. But it's clearly. So here IP1 is less than IP2. IP2 is big. Why? Radius, if you see, radius X and X plus. This X is big. So when the radius is big, atomic radius is inversely proportional to ionization potential. X radius is big, so IP is less for X. That's why IP1 is smaller than IP2. Similar way, if one more is there, IP3 like this. So these are the factors actually. IP is inversely proportional to, you can write like this. IP is inversely proportional to atomic radius. Atomic radius if big, IP is less. For X, you have IP1. For X plus, you have IP2. For X2 plus, you will have IP3. Size is like this, so IPs are like this. Sir, here plus 2 is there, no sir, this is IP2, no sir, few people will ask. No, from X2 plus you are removing third electron. One electron you remove from X, so IP1. Second electron you remove, after one electron removed, second electron you remove, that is IP2. So after IP1, IP2 exists, after IP2, IP3 exists, like that. One more, as charge increases, positive charge increases, then IP increases. Third factor, as nuclear charge increases, then IP increases. And fourth one, IP is inversely proportional to screening effect. So as the screening is more, that means going away from nucleus, certainly attractions will be less, so you can easily remove. Okay, next one more, fifth one, ionization potential is directly proportional to penetrated. Penetrated means attracted towards nucleus. Penetration power. Penetrated means attract. So the penetrating order also same, S greater than, P greater than, D greater than F. Then what is the difference? Screening by inner subshells. Here screening by whom? N minus 1S, okay, N minus 1P, those are protecting. Who is penetrating? NS, NP, they are penetrating. Outer is penetrating, inner is protecting. Inner subshell is screening, outer subshell is protecting. Like that you have to consider. And one more, if atom has a stable electronic configuration, then IP will be more. So sixth one, one is duplet configuration, inert gas configuration, and half filled and completely filled electronic configuration, and pseudo inert gas configuration. If you see all these things, if any atom or ion have these configurations, then they have more IP. Duplet means 1s2, like 1s2, 2s2, like this. Simply ns2. Inert gas means ns2, np6. Duplet means simply generalized manner, I will write ns2. Half filled or completely filled means p3, d5, f7, they are half filled. Completely filled means p6, d10, f14, they are completely filled. Pseudo inert gas configuration means having 18 electrons in outermost, that is ns2, np6, nd10. Total how many? 18 electrons in outermost. Examples, if you see, zinc, Zn 4s2, 3d10, Zn plus 2 electrons you have to remove from 4s, so you are having 3d10. So 4s before what you have? 3s2, 3p6. So Zn2 plus configuration is what now? 3s2, 3p6, 3d10, 4s0, because 2 electrons you removed. Okay, so now this is called pseudo inert gas configuration. Then pseudo inert gas is more stable. Understanding? Suppose if you want to remove electron from calcium plus 2, if you want to remove electron from Zn2 plus, which is difficult means IP of calcium 2 plus is more, because calcium 2 plus has inert gas configuration. If you see its configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, actually calcium 2 plus, calcium. So you have to remove 2 electron. 2 electron means 4s0, because last electron you have to remove. So it has what configuration? Octet configuration. So it is more stable. This has what configuration? 3s2, 3p6, 3d10. This has pseudo inert gas configuration. So than pseudo inert gas configuration, inert gas configuration is more stable. Please, okay, understand all these things. Okay, you have to work hard. So this is a very, very important thing. Okay, so now what will happen? IP from top to bottom decreases, because atomic radius is inversely proportional to IP. But left to right, IP depends on configuration. Depends on what, sir? Configuration. What configuration? Electron configuration. So ionization potential from left to right, what happened? Left to right, actually atomic radius decreases, so IP should increase. But IP values also depends on electronic configurations, as I said. But top to bottom, IP decreases. So this is very, very important. Ionization potential from top to bottom, IP decreases. But left to right, suppose lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, if you see. Actually we expect like this, because in this way atomic radius decreasing, it must increase. But that also depends on configuration. Duplet configuration, you know, 1s2, 2s2. This is a duplet configuration, completely filled. And boron 1s2, 2s2, 2p1. So beryllium has more stable configuration, so this is more stable. Next here, nitrogen has more IP, so IP I am saying IP order like this. It is 1s2, 2s2, 2p3. Oxygen 1s2, 2s2, 2p4. Who is more stable? Oxygen. Sorry. Nitrogen is more stable because it is having half filled. Half filled is more stable. It is not completely filled. So IP1, if you see, nitrogen is greater than oxygen. Actually, it should be like that. Oxygen should have more because size is less. But nitrogen, due to its configuration, it is more. What more? It is having more IP. But IP2, if they ask to remove second electron like that, if they ask, then nitrogen less than Np plus is less than O plus. After removal of one electron, it will become 2p2, 2p3, n plus means one electron removed. After removal of one electron, 2p4 become 2p3. Now this become half filled. So IP2 will be more for oxygen. These all things you have to remember. Okay, very very important. Even same for the next period. Even electronegativity shortcuts I was given. Go through those. Electronegativity, what happened top to bottom? Decreases. Electronegativity left to right increases. Highest electronegative atom, fluorine. Electronic affinity is amount of energy released when electron added to particular neutral isolated gaseous state atom. Highest electronic affinity atom is chlorine. Highest electronegative atom is fluorine. Okay, remaining many things like basic characteristic character and all we learn already in P block everywhere. So still we will discuss in our next class, and you please you should be more patient. Okay, and please read all these things. We will do definitely best. Okay, I'm requesting you have to practice everything. Definitely periodic table already over. Just please go through all those things. You can easily understand. Thank you very much. Take care.